Let's have a look at our first example. So here I've given you an expression, 6x squared y minus 7xy cubed plus 8xy minus 9. So the expression in question, this one over here that I've now put in a block. That expression we're going to use to answer all of these questions. First question being, how many terms are there in the expression? So quickly in the chat, how many terms do you think there are in this expression? Nice, guys, well done. Okay, so there's 4 terms. If you're not too sure why, remember the plus and minus signs separate your terms. So here we've got 1 term, 2 terms, 3 terms, 4 terms. There's 4, and I know that because of the plus or minus signs. Second question is asking us for the constant term of this expression. So again, in the chat, tell me what the constant term of this expression is. Let's see if we agree. Right, so majority is saying -9. I think we can all agree that 9 has to feature somewhere. Remember, your constant term is the term without a variable. So we need to go to our expression. There's our term without the variable. Now, guys, very importantly, what you need to remember is that the sign in front of the term is that term sign. So this term is -9. So the constant is -9. Please remember to keep the sign with the term. It is a -9. It's the constant rather is -9. Good. Okay. Now C and D are asking pretty much the same thing, but we need to read the question carefully. So for question C, I have asked you what is the coefficient of xy cubed? And for question D, I have asked you what is the coefficient of just xy. So in the chat, I want you to give me answers for C and D. Remember to number them properly. So C and then D. And then we'll chat about why they are the same, but also why they are different. And remember, based on what I've just said about the constant, remember signs. Good, keep those answers coming, well done. And I saw all of you who initially put C, well done. Okay, so guys, C and D are basically the same question, but slightly different. Firstly, they are the same because it's asking for the coefficient. Remember, coefficient is the number that sits in front of your variable or groups of variables. It is the number being multiplied with the variables. Say, for example, you had 3x, that is your coefficient. It is being multiplied with the x, it's 3 times x. So if we now look at the coefficient of xy cubed, here is my xy cubed term. The number in front of the xy cubed is -7. So as you guys have told me, the coefficient there is -7. D is a bit different because even though we're still talking about xy, I'm now only talking about, or I'm talking specifically about the term that contains only xy. So that is now term 3 that has x, y only. There's no exponents of cubed or squared or anything like that, just x, y. So it's a completely different term that I'm looking at. And here we can see that coefficient is +8. So the point of me asking you these 2 questions is mostly to get you to read questions properly. If you made a silly mistake and didn't read the questions properly, you could easily mix up the first 3 terms because all of them contain x and y. you have to be very mindful of which term I'm talking about, and that you're going to see by reading the question properly. Okay, so that was just a test of make sure you read questions properly. Right, question E, I've left off some information, so let me just fill that in. Right, so I'm not a huge fan of these questions, mostly because this is like, I'll ask you this question once and they never really talk about it again. So the degree of an expression, let's just start with a basic sort of definition. When I talk about the degree, I'm talking about the highest or the biggest exponent. Now, because in this expression, I have got both X and Y variables, I needed to be specific. So that's what I needed to add in. I needed to be specific and say, what is the degree of this expression in terms of X? So essentially what I'm asking you for here is what is the highest or the biggest exponent of the X variable? So we go up to our expression, and now I go and look. I'm just going to take all my scribbles off. Please don't raise your hands until I say so. And we look at all of our X variables. We want the one with the biggest exponent. The biggest exponent is here, that X squared. So the degree of my expression is 2. That's it. Okay, it's a bit of a random question. And we don't really, like I say, we don't really like go into more detail on it, but degree becomes very important as you start to work up in complexity, especially with equations, because knowing the highest exponent of an expression when you now work with an equation. So let's say, for example, you had X squared equals 4. Knowing that the degree of this equation is 2 tells you that you should get 2 answers for X. If this had been cubed, you should get 3 answers for X. If the degree had been 4 answers, etc., etc., etc. So degree helps us when we start working with more complex algebra, equations, etc., etc. So I want you to try this by yourself. If I had said the degree in terms of Y, what would the degree be? On the chat, sorry, I just sort of said words and then stopped. What would the degree be if I asked you in terms of Y? Good, guys, well done. So we go and look at Y, look at all of your variables Y, pick the one with the biggest exponent. So the degree would be 3. Very nicely done, grade 8s. Okay, so I'm just going to stop here, mostly because this was definitions. There is another question, we'll get there. Screenshots, and if anyone now has a question, you are welcome to raise your hand before we finish off the last question F here. So if you've got questions, please do raise your hand and ask me. Otherwise, take your screenshot. I will make it all small again, so if you would prefer to screenshot when we're done with F, that's fine. But have a think, tell me if you've got questions, otherwise we're going to have a look at F. So again, these are all like the definition, knowing what words mean in maths. Okay. Right, question F, I have now given you values for X and Y. So I've just been lazy, I'm copying the expression. I have said, if X equals -1 and Y 2, determine the value of the expression. So grade 8, the second I give you specific values for your variable, you need to be using substitution. This means that you are replacing all X's with -1 and all Y's with 2. So every time we see an X, we're going to replace that or substitute a -1. Every time I see a Y, I'm going to replace it with a +2. You are substituting. Okay, so I want you to give it a try. Let's see what happens. Give this a try. Please remember though, for example, 6x squared y. If you break down what operations are happening here, you've got 6 times x, which is being squared, times y. That whole term, you are multiplying x, y, and 6. So substitute in for me. and let's see what you get as the value of your expression. Clearly haven't been teaching for a while. Put your answer in the chat, and then we'll see if we agree. Often, guys, these questions tell you to do it without a calculator. So you do need to be able to do these things in your head. Obviously, use a calculator to check your answer. Like that, just check with a calculator. But as long as you can show you're working out, you're fine. When I do the answer, I will do all steps. So this is what my answer looks like is how yours should look if I tell you no calculator. Okay, so remember you're substituting. All I'm writing down now is the value substituted in. So I've replaced all my x's with a -1, all of my y's with 2. And remember, you are multiplying within a term. 6xy means 6 times x times y. So remember that you are multiplying. And guys, please use brackets when you substitute. For that exact reason, you need to make sure you're multiplying. If there are exponents, you need to make sure that you are applying the exponent correctly. Okay, I'm going to give you 1 more minute and then we'll go through it. And remember, I want the final simplified answer. So once you've multiplied, added, subtracted, all of those fun things, what is your final simplified answer? Right, let's have a look. Okay, so if we just look at this first term, I'm not going to do this for all of them, but just so that you can see. 6 times -1 squared times 2. That's what that first term is asking us to do. So BODMAS tells us deal with the exponent first. -1 squared means -1 times -1. A negative times a negative is a positive, so times +1 times 2, which means the value of this first term is 12. And I'm going to do the same thing with each of my terms. So if I now go to term 2, I've got -7 times -1 times 2 cubed. Now 2 cubed, remember, means 2 times 2 times 2. So we've got okay, it's fine. I'm not going to get annoyed. I'm not going to get upset. We've got -7, there we go, times -1, and 2 times 2 times 2 is 8. Now, guys, be careful of signs. Negative times a negative is a positive. So 7 times 8, which gives us 56. So my second term is plus 56. And then I keep going like that. So if I now go and have a look at my third term, 8 times -1, -8, times 2, -16. And then last term is just -9. There's nothing going on there that I need to stress too much about. So now we go and add and subtract all of those things. Again, just do it on a calculator so that you know that what you're doing is right. But if you can do this in your head, well done you. 12 plus 56. I'm using a calculator because in my head today it's not going well. Is 68 minus 16 minus 9 gives us 43. I got a different answer with the other class, and now I'm questioning all my mathematical skills. That is fine. Yes, and I also got negative 69 initially. Guys, have I done something really stupid? Anyone picking up on any stupid mistakes I've made? Let's see what I did.
So
Oh,
far,
I'm right.
yeah. So far,
I'm
that's
right.
what I was checking. I'm like, oh, that looks right. Unless it's...
No, I'm just losing my mind. It's fine. Okay, so 43, guys. 43 is your final answer. 12 plus 56, 68. 68 minus 16, 72. 72 minus 9, 43. Okay, so if I say without a calculator, what do you need to show? You need to show substitution. You need to show you're working. If that means that you're doing this stuff on the side here, that's okay as well. But as long as I can see that you've gone to each turn, and then obviously you need to show your answer. All right. If not, obviously just chuck it in a calculator. But if it specifically says, and often these ones say no calculator, show everything. Okay. Sianda, well done. Triple. No, 43 is perfect, Triple. I just had a bit of a moment. 43 is the correct answer. I've got it there. 43 is right. Yes, Teto, I think I made the same mistake. That's why my mind was going a bit crazy. So Triple, 43, positive 43 is the correct answer. I just had a moment, guys. It's fine. We all have them. Alrighty, so I said I would make this a touch smaller in case you wanted to screenshot everything at the same time. There you go. Take your screenshots. I'm hoping I've answered all of the questions, but if not, now is the time to raise your hand and ask. Otherwise, screenshots, and then we're going to have a look at another example. Okay, screenshots. I'm moving on. Right, so guys, that's all well and good. You need to know the terms and definitions and so on. But what we really sort of focus on in algebra is being able to simplify expressions. So if we have a look at this first example, we're starting off nice and easy. If I have a look at this first example, all right, when we are simplifying an expression, what we always want to do is we want to make sure our order of work is correct. So we want to make sure we're applying BODMAS. And we always want to double check that we have added and subtracted our like terms. So we must follow BODMAS, and we must remember to add and subtract like terms. Now, like terms, remember, are terms that have the same variable or groups of variables. Let's do that. As well as the same exponent or exponents. Okay. If that applies, they are like terms and you can add and subtract them. So if we look at this first expression, what we want to do is we want to identify our like terms. So use your highlighters, use your colored pens, whatever. Identify your like terms. So I'm just going to start with term 1. It's got an X in it. So I want to find all terms with X's in it. The only other term would be minus 5X. I'm done. No more X's. So I move to my next group of terms. These are terms with Y in it. 4Y and minus 3Y. No more. I'm done. What I then see is that I've got this plus 9, that constant all by itself, which is fine. But now that I know what my like terms are, I can add and subtract them. Now, some people like to group their like terms together before they start adding and subtracting them, which is absolutely fine if that is what you want to do. So all I'm doing here, guys, is I'm grouping together all of the X terms, all of the Y terms, and the constant term. If that's what you need to do, that's cool. Personally, I don't do it, but that's just me. Once you've got your like terms, you can add and subtract. 2x minus 5x, negative 3x, 4y minus 3y, positive y. If you want to put positive 1y, absolutely fine. And then that plus 9 just stays there. Can't do anything with it. It's got no like terms. Now, guys, this is my final answer. There are no more like terms. So we're done. We have simplified fully. That's it. Okay, so this was just a little reminder of like terms. What I want you guys to try for me is question B and C. So in the chat, put your answers for B and C. We've just discussed this idea of like terms. So identify for me your like terms and put your simplified answers in the chat. Okay, guys, let's see those answers. Remember to number your answers so that we know which is which. And make sure you're simplifying. Otherwise, you're not following the instruction. Okay, 1 more minute. And then we're going to have a look.
Let's go, let's go, let's go, let's go. Remember to also use colors. You can highlight like terms. I see number B is getting done. Nice, my people. Nice. My son wants to join you in doing this, in doing this equation. Nathan, what's -6 + 7?
He's ready.
Yeah, he's ready. He's ready to write everything down.
He's going to be a little mathematician like his mom.
He has no choice. I see Ompa is already giving us number C.
Nice, guys.
Let's go, guys. We hope that you are writing in your book, right? So that we can do the corrections together. It's always nice. We always prefer it that way because you might be writing on the chat and the message goes up. You don't even see where you put your answer. And you might think, oh, I got it correct, but maybe you've missed the sign or you've missed, you know, a term. You never know. So it's always right to write it in your book. You guys are doing great, by the way. I'm loving the small class that we are having today.
I know. Sipasihle, yes, that's part of geometry. So once we're done with equations, we will. Right, guys, you are doing really well and you deserve a break. So let's go through these and then we'll have a bit of a brain break. Right, identify your like terms. Like Yolanda says, get your colors, get your highlighters, do what you need to do, and let's identify. So remember, like terms, same variable or groups of variables. So what that means is if there's an xy, all terms must have an xy to be like. So the negative 6xy and the negative 2xy are like terms. That's it. I've got no more terms with both x and y. 7y and 8y like terms, and then Shane, the x term is by itself, just plus 3x. If you need to regroup, by all means regroup, that's absolutely fine. If you don't need to, that's also fine. Minus 6xy minus 2xy plus 7y plus 8y plus 3x. Add them together, negative 6xy minus another 2xy, negative 8xy. 7y plus 8y, positive 15y, and then the plus 3x. No more like terms, always just double check just to make sure, but no more like terms. And so that's your final answer. There we go, that's better.
Teacher Sam, to disturb, who got this one correctly? Please do hands up if you got it correctly. If you got it wrong, just put sorry, not hands up. Sorry, Listedi. I meant my people, y'all can listen. Y'all are good students. I wanted to say thumbs up. My mistake, guys. You know, your teacher Yolanda gets too excited. At least Sipe is giving me a so please don't be shy when you got it wrong. Please just put thumbs down, okay? It's just Teacher Sam and I can see exactly how many of you got it right and how many of you didn't get it right, okay? But I see, hey, Teacher Sam, everybody is saying, yeah, we win. We are winning at this thing, so we move.
And guys, remember, if you don't get it right, it's also not the end of the world. But like Yolanda always tells us, do corrections so that we know where we went wrong. Alrighty.
Yeah. Nice, guys.
Oh, I'm just gonna have a moment. Zimi, I went to exactly the same school as you in primary school. Exactly the same. I knew that badge was familiar. It's been bugging me the whole lesson. So Zimi's badge is the same primary school. Okay, I'm now on it. Wow. Thank you. It's been bugging me. Thank you. I thought so. I went to the same school. All right. Okay, right, let's go. Question C, like terms, guys. So get a highlighter, x squared. Remember, same exponent. So all the x squareds we're going to highlight. There it is. We're done. Then we go to, oh crap, panic to highlight it and change. Then we've got the x terms, negative x and 9x. Then finally, what's a little bit new here is we've got multiple constants. We've got a plus 6 and a minus 11. So just bear in mind that unlike what we had in question A, your constants can have like terms. So there can be multiple constants that you'll need to add or subtract. And we see that now in C. Okay, okay. If you want to reorder, by all means do it. Like I say, I don't reorder, but it often is quite nice to reorder because what I notice, especially as you get to grade 10, 11, 12, what often happens is that you sort of assume you know what's going on, and you do, but then you make silly mistakes. So when the expression's really long, you forget some of the like terms. And so if you actually group them together, it does make life easier. Okay, so x squared plus 3x squared, 4x squared, minus x plus 9x, positive 8x, 6 minus 11, negative 5. All right, so we've simplified. Again, double check. Are there any like terms? No, they aren't. We're done. All righty, guys. So screenshots. I'll just go back to A just in case. Take your screenshots here. Important things, like terms. Obviously, check for BODMAS. That's also important. But when you're just dealing with addition and subtraction, what you're needing to look for are like terms. And if you mess up your like terms, then unfortunately, it means your simplification is also a little bit dodgy. Right. Questions? While you're screenshotting, you can raise your hand and ask me. If you have no questions, that's cool. We're going to take a brain break. And then we'll have a look at some more complex like term situations. And guys, just a reminder, we know that obviously with load shedding, sometimes signal, network connecting or joining the lesson, we understand that sometimes you're late, sometimes you have to leave early. We get it, don't stress. Remember that the lessons are recorded. Okay. Righto. Brain break, guys. Just want to have a quick look-see here. So we didn't have any newbies, but just as a reminder, because we haven't done one in a while, brain break, free of charge, you get a maths joke. And then what we want to happen is sometimes I mix it up and give you like a guess the same sort of thing. Hint, hint, nudge, nudge, they're coming up. But here we've got a brain break where we need to find the value of the very last equation down at the bottom here. So you need to figure out what, I think this is a train, what the trains are worth, what the bus is worth, and what the cable car thing is worth so that you can find it. Please though, make sure that you are checking whether or not there's 2 or whether or not there's 1. It changes the value. So have a look at that. I'm going to make it a bit bigger so that hopefully you can see those doubles. Remember the way we do this. First correct answer for this final answer on the chat will explain it to us. So what we want to see on the chat is only this final answer here. Yolanda and I both know what it is, so we're waiting to see that final answer. And guys, remember, this is like solving an equation. You're solving for an unknown bus, so you could make all of those buses X if you wanted to, or trains, or whatever I said they were, and you can solve for your unknown. Settle. How did you do that so quickly? Wild scenes here. Oh no.
Really? At all.
Like I barely had time to think about anything, and here Teto is. Well done.
Well done, Teto. I guess y'all, well, Teto was too fast for everyone. So Teto, you can raise your hand and then you can explain to the rest of us. But you guys are just, y'all amazing.
I don't even think I did it that fast. So well done.
You know, well done. Raise your hand so you just can explain step by step. Hey Teto, like this, those ones who didn't get it, they can get it. And I still need someone to explain the joke to me, guys, if you got the joke. But later on, let Teto finish here.
Hello, ma'am.
Hi, Seto.
Ma'am, so for the first one, I saw that there were 2 trains, so it ended up being 42 divided by 6, where I ended up with 7.
Okay, so 1 train is 7.
Yes, and then 2 would be 14.
Okay, so guys, just quickly, 1 individual train, 7. So like Teto says, 2 of them together, 14. So 14 plus 14 plus 14, 42. Yeah, keep going.
Ma'am, so then for the second one, I tried to amass everything I had. So I knew that the trains were 14. And I just looked at it and I saw that the answer had to be 150. I don't know how I did it, but I knew that the boat was 10 for me to end up with 140, then plus another 10 for 150. And since there were 2 boats, 1 boat should have been 5.
Okay. So guys, just quickly, I'm going to interrupt. BODMAS. So Teto said 14 times 10 is 140, and then that follows BODMAS. I only add the 10 later. So please remember BODMAS. Okay, and like Teto says, 1 boat is then 5. If 2 boats is 10, 1 boat is 5. Cool. Teto, keep going.
Ma'am, so then for the other one, the second last, it was 1 boat times 1 boat plus a helicopter. Since I already knew that the boat was 5, I had 5 times 5, which is 25. And I subtracted 25 from 31, and I ended up with it's either a helicopter or one of those thingy things, like by Table Mountain that you used to get up. I ended up with it being 6.
Good.
So then the total thing would have been, at the bottom, there's 2 of, I'm gonna go with cable cars here.
Yeah.
There were 2, so it was 14 plus 7.
Why 14?
Oh, not 14, 12. Sorry,
Oh,
ma'am.
yeah. No, that's good.
Plus 7 times 10.
Yeah, times 10. What do we do first? The addition or the multiplication?
The multiplication.
Good. So 7 times 10, 70, plus 12 total gives us a final answer of
82.
excellent. Okay, guys, there you go. So it's solving an equation. Teto's explained it. I don't think I need to say anything else. Take note of your doubles, take note of BODMAS, and you get your final answer. Okay, there's your math joke. Again, if you would like it. Do we all get it? So if you don't get it, this number is the first sort of digits of pi. Pi is 3.1415, blah, 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 blah. So if you take pi and you take the pi out of opinion, you are left with onion.
Sorry. I didn't get that. I was looking up like an opinion without pie is just an onion. And I'm like, what the heck? Where do I subtract this pie? Oh my word. Guys, I didn't get that part. I don't get the joke of today. My people need to explain to me, but whoa. Okay, that's clever. And
You weren't alone.
It's just an onion.
You can see what I spend my spare time doing. I just find math jokes.
These jokes are so lame, but in a funny way. You can only get it if you're a geek. So whoever laughed there, it means that, whoa, yeah, you're a part of us.
Alrighty, grade 8. We've got 15 minutes. Let's do this. So what I want you to try, I'm just trying to decide what I want to do here. Okay, so I want you to try the first example here in example 3. By yourselves, give it a try. I want you to simplify it for me. Let's see what we get in the chats. Answers in the chats. You're simplifying question A, just A.
Let's go, my people. Let's go. Let's have those brain cracking. Remember, write it on your book, and then later on you can write it on the chart so we can see that you are done. Let's go, Shumi. I see you, girl. You're like, yes, ma'am. I'm just, yeah, trying to do my work.
You guys are doing so nicely. And I know we've done a lot of this. So this is why I'm sort of just throwing it to you and letting you practice, letting you revise, letting you make sure that you know what you're doing. Okay, I think this is quite straightforward, so I'm going to go through it. If we get our like terms, we've got our x squared terms and we have our x terms. What's quite nice with this one is that I don't have any lonely terms. I don't have any that's just one by itself. All of them have a partner at least. We can group them if you want to. That's a little bit ridiculously of a thick pen. Let's maybe sort that out before we carry on. X squared minus 3x squared plus 15x minus 12x. You don't have to group it again, guys. If you want to, you can. If you don't, you don't. X squared minus 3x squared is negative 2x squared. 15x minus 12x plus 3x. These are not like terms because the exponents are different. Different exponents, not like terms. All right, so that's it. We've simplified. Now, the ones we've done so far are quite easy to start off with, but we can definitely make things trickier just by needing to identify like terms. So I'm doing a bit of jumping here, but you know, who's a maths teacher if they don't jump around? So what I want you to have a look at is this question here. If you want to number this B, that's fine, of your next example. I want you to have a look at the situation that we have going on here. I'll go back so that you can screenshot A in a second. Let's first try this one and then we can do our screenshots. Okay, so in this situation, we've got a lot going on. We've got A squareds, B squareds, ABCs, there's a lot. We need to identify our like terms. So again, go back to what a like term is. It's got the same set of variables and all of those variables have the same exponents. Now, what I want you to notice, and it's really only in this fourth term, is that over here, those variables are not in alphabetical order. So if looking at this stresses you out and makes you panic about needing to find like terms, put all variables in alphabetical order first. It will make your life so much easier. So if we start with that, all the other terms are fine because it's A, B, C, obviously A squared, B squared, C, plus 6ABC minus 7A squared, BC. But now this fourth term, let's reorder it. A first, so A squared, then the B, so B squared, then the C. And that reordering hopefully helps us identify our like terms, because what I can now see is that I've got a term with A squared, B squared, C squared, and that is then a like term to the two A squared, B squared, C squared. So once they're in alphabetical order, it helps us identify our like terms so much easier. They are like terms again because they have A, B, C, and the A, B, and C all have the same exponent. That therefore means that the 7A squared BC is a completely separate term because only A is squared. It's not the same as the others. And then completely separate again, we've got the ABC terms, again, because all of those exponents are 1. All right, so when you encounter something like this, and sometimes we like to throw in something like this to be mean, well, not to be mean, but to challenge you. If it is stressing you, make sure that all of the variables in each term are first in alphabetical order. It really does make identifying like terms a little bit easier. Right, if you want to reorder this, that's fine. I think for the purposes of this more complex one, let's reorder it. So when I say reorder, guys, all I mean is I'm putting my like terms next to each other. And if you want, especially because, again, there's a lot going on here, just highlight for yourself or group for yourself your like terms again so that you know exactly what you're working with. And then we can go and add and subtract our like terms. So the 2A squared, B squared, C squared plus A squared, B squared, C squared gives us 3. A squared, B squared, C, yeah, that thing. Okay, too many letters, too many things. That's my orange group. Now my green group, 6ABC minus 4ABC, positive 2ABC. And then we've just got that minus 7A squared BC at the end. None of these are like terms, so I can't do anything with it. That is it. Okay, so be very mindful that as we start to add more variables with exponents and all of those things, we need to be very careful about identifying our like terms. Alrighty, so guys, take a screenshot of this. I'm going to go back to question A for you to take a screenshot of. I'm going to give you one to try by yourself, and then I think we'll probably call it. We'll see where we're at, but screenshot, I'll go back to A for you to screenshot, and then you're going to try one of these by yourself. Okay, that's B. Here's A in case you didn't get a screenshot of A. Right, and then I want you to try. Let's try B and C. I think you can do both in the remaining 8 minutes. Right, so, okay, if it's going to upset you, this is question C. This is question D. If it's not going to upset you, it doesn't matter. Try those two for me. I'm going to go with C and D because it upsets some people. So C, then D. Give them a try. I want answers in the chat. Make sure you number your answers. My little cat was crying outside the door, so she's come to join us. Okay, guys, like terms, remember if you need to reorder, do that. Like terms, same variables, same exponents. Okay, 1 more minute and then we'll go through. I've so far only seen one answer for C. Okay, so maybe 2 more minutes. Remember, guys, if it helps, put your variables in alphabetical order so that you can find your like terms. Because it is absolutely fine to rearrange variables. X, Y means the same thing as YX. Okay, 1 more minute, then we'll have a look. Right, grade 8, let's check. Okay, so if we start with C, remember same variable, same exponent. So if I just start with the first term, this is terms that have an x squared, a y cubed, and a z. So I go along and I check for terms that have an x squared, a y cubed, and a z. The second term has an x cubed, so I can immediately ignore that. The third term also has an x cubed, ignore. Fourth term doesn't even have exponents, ignore. But this very last term has got an x squared, a y cubed, and a z. So those are my pair of like terms. Obviously, I've reached the end of my expression, so now I go back and I get my next group of terms. So now this is x cubed, y squared, z. Next, or third term, is an x cubed, y squared, z. So those are like terms. And then sort of by itself, is the term that was just negative 7xyz, there were no exponents, so it can't be a like term to any of the others. Again, if you want to group your like terms together, that's fine. Let's just do it because there is a fair amount going on here. We've got 3x squared y cubed z plus 4x squared y cubed z. That's a weird looking z, but whatever. So was the first one. We'll just roll with it. Plus 2x cubed y squared z minus 6x cubed y squared z minus 7xyz. So all I've done is I've grouped my like terms. And if you want to re-highlight them so that you know what it is you're working with, that's cool. But essentially, you've just put them together. Now you can go and add and subtract them. So the 3x squared y cubed z plus 4x squared y cubed z is 7x squared y cubed z. It's so many numbers and letters. That's my blue group. The green group, 2x cubed y squared z minus 6x cubed y squared z is negative 4x cubed y squared z. And then we just have that minus 7xyz at the end. It didn't have any like terms to it. That's where I end. Always remember, always double, triple check that you don't have any more like terms. I don't move on, or done rather. Right, now, just quickly, because I see Umfa said, did I get it wrong? Guys and Teto, these questions are not hard. You get them wrong because of silly things like a typo. You write a sign down incorrectly, or you write an exponent down incorrectly. You forget to consider one of the terms. So it's not that you don't know. You guys know how to do this. Again, it goes back to read your questions carefully, copy down the question correctly, and make sure that as you go from step to step, you're copying everything down accurately. Because like I say, where most of you go wrong is not a lack of understanding. It's silly mistakes. Okay, so just always double check yourself. And at the end of your test and exam, when you're sitting and you're twiddling your thumbs for 10 minutes, you need to be checking these silly things. Right, so exactly, Omfa, the exponents throw us off. There's so many variables, there's so many exponents, we need to be double, triple checking. Right, now for question D, what we need to bear in mind here is the fact that all of them have A, B, and C. So what we need to double check, or what we might need to do for ourselves, is put it in alphabetical order first. So first term is already in alphabetical order, it's A, B, C. The second term is negative 8 BAC. Let's just put it in alphabetical order. A, B, C. Remember, X, Y is exactly the same thing as YX. It means the same thing. So you reordering it doesn't make a difference. Third term, 11 CBA. Let's put in alphabetical order. A, B, C. Fourth term, CAB, alphabetical order, A, B, C. Because it's all in alphabetical order, hopefully what you can now see is that they're actually all like terms. They all contain ABC with exponents of 1. And so what that means is you can just add all of them. 7 minus 8 is negative 1. Negative 1 plus 11 is 10. 10 plus 1 is 11. So we get 11 A, B, C. They were all like terms. They all had the same variables and the same exponents. No problems.